Hello, it's exciting times today. We're going to do a scrap heap challenge. Remember that? I definitely have enough scrap kicking about to count as a heap, and this will be a challenge. I think I've got all the bits lying about somewhere to make a power hammer. Right, I've done some scribbles here which show what I'm intending to do. This is a guided helve power hammer. So here will be a wheel on a stub axle, and underneath it will be a motor on a hinge, and this is a column in the middle and a leaf spring, and a bit of I-beam here holding the guide bit, and the actual hammer will be a section of railway track, just a little section about 12 inches long, and that'll smack down against another section, and that'll be on something sturdy here as the anvil, and the whole thing will be on a base plate. So let's go hunting. Okay, the first bit I'm fairly confident of. Here we go. Some I-beam. I've got loads of this. So some of that will do. Where are we? On this bit here, and maybe another bit here, maybe even for the base. That's good. This was actually supposed to be holding up the roof of the barn, but where I was storing it, right outside my workshop, when I had the workshop in town, somebody stole it, which was distressing. And then I found it and retrieved it. Yeah, after some words, but by then I'd already built the roof of the workshop, so it's now surplus, but yeah, I took it back anyway just to make a point. Anyway, what's next? Now then, for the main leaf spring on top of the machine, I do have a leaf spring here, and it's even got both its ends. Pretty sure it's a Land Rover one. So this leaf spring here, there is a leaf spring under all this moss and stuff. It's going to turn into some weaponry. It's good steel for that, I think, for making knives and choppy things. Anyway, here we go. I think this will do for the main column. So the central column, which is going to have the beam structure on top. This is nice thick wall tubing, it's not just a bit of flue pipe. This is good thick wall stuff that I got for extending my spiral staircase to take it all the way up inside the barn. So it did quite well. This bit here, I'm thinking 20mm round for that, and I want to be able to adjust it to adjust the stroke of the hammer over here. So my plan is to use one of these that's spare. It's a top link from a 3-point linkage off a tractor, and it's threaded at each end. One end is reverse thread and the other is normal, and there's a couple of these kicking about somewhere, but that essentially means you can wind it in the middle there and it'll pull the two ends here closer or further apart. So that worked well for that. Then so this is another stash of Land Rover bits. But also in here I've got some of my old shot blasting equipment. This is a rather nice motor, which hopefully hasn't seized. It's been sat under a Land Rover bonnet for a year or so, so I think it will go. Let's see how it's going. HP 1.5. I think that will do the do, and it's a nice, reasonably soft start as well. It's got a big fat capacitor in there, so because this will have to run off a generator, so I think that will do the do. Come on. There we go. Whew. That's what I was looking for. So this is the basic elements, I hope, of a guided helve hammer. So by helve, helve is a word, I had to look it up. Now I can tell you. It's related to the old word for handle. So basically the helve, is the arm of the power hammer. So in this case it's going to be this spring. So this is a leaf spring. I think this is the rear leaf spring from one of my old Land Rovers. I think it is. And I'm hoping it's got some spring left to it. Well, that remains to be seen. So the reason for using a spring is that instead of just an arm, which is quite a dead hit, the spring, I'm hoping, will have more of a thwack as it goes down. And it needs something to change the rotary motion of this motor into reciprocating that. So we need a tyre, preferably a tyre already on a stub axle. And I've got an idea where I can get that. So let's go and have a look. And there we have it. So this, the reason I was so keen to get this is because it's got I can put the tyre on here which will engage on the motor, and then it's got all this to use for the mounting. So it's all built in there. This is even more useful than having the normal axle going like that, because this arm I can weld to the frame or mount in whatever way I dream up. So yeah, there we go. Unit. I think it's the ideal. Like I say, never built a power hammer, never even seen one like the one I'm trying to build, so yeah. If I knew what I was doing, it wouldn't be so much fun, would it? Right, drag this to the workshop. The only other option that I could have used for this part of the setup would have been a Range Rover axle, and apart from the aggro of actually extracting one, which would have been considerable, it's just that much more mass flying around. And yeah, imagine this is quite a dinky wheel really. This is a 13-inch wheel. The Range Rover one is 16, and yeah, so it would have been yeah, this is better. I'm happy with this. I haven't started for quite a while. Mr. Postman. There we go. Hoping it's my bearing. They seem incredibly cheap for what they are. There we go. So we're going to have 2 of these at the top of the column for the rocking beam. Oh yeah, no complaints with that. Some of them were pressed steel, it seemed pretty flimsy. This is cast. £6 each. Right, well that's good. Now I can build the top of the column and then stick it onto that frame. So the next bit is to attach the spring. So it's going to be that'll be the helve part of the setup. So the rocking spring needs to attach to the central column, and I'm going to use my new pillow blocks for it. Now I can't see any reason, although I haven't seen this done on any of the other power hammers that I've seen on YouTube or on the internet and other places, but I'm thinking it'd be easier if I get a plate, make up a plate and fix the pillar blocks on like that, and then have this as a fixed axle going through the top of the column. That seems less work overall to me. But yeah, like I say, I haven't seen that done anywhere else I can think of. So maybe there's a reason why that doesn't work. Anyway, so this is what I'm going to do. So I can get this. Right, I was just about to do a little extra bit and say that even though doing it with the flat bar like this was a bit of a faff, it meant that it could conform to the spring, which actually goes like that on the top bit there and like that on the bottom. I was about to say that when I managed to crack it, so I'm not sure if this is going to come up on the camera. So that's a bit of a setback at the last minute of the day. Fortunately, I had ordered more of these. I ordered an extra 2 because for my dumper project. So I'll swap that with one of those for now, but I've got to think of some way of stopping it happening again as soon as this is cranked up. Right then, it's the following morning, and having thought about it overnight, I'm going to do away with this idea, I think. I brought the camera down so you can see the issue. So hopefully you can see what's happening. So the springs, this leaf does that, and the top, well, the rest of the pack does that. So when I tighten it up, the nuts try and pull this down. So that crack just did that. Obviously cast iron is really brittle. Although it's strong in compression, it has no tensile strength to speak of. So last night I marked out some angle iron which I was going to put on there, and then put this on, and that would probably work, but when you clamp it up it's always going to be trying to move this angle iron, and then hence the bearing on top, so it's always going to be trying to pull that in. And I figure once this is actually clamped together tightly and it's rocking with all the forces that are going to be involved in it, there's always going to be a bit of movement. So perhaps that's the reason why in all the hammers that I've seen, the bearings, bearing in mind this is upside down at the moment, the bearings are like that on the top of the column, and there's an axle attached to the spring. So this is the kind of detail that I wish there was a bit more of on YouTube or in the descriptions of building the hammers that I've read. So there is now. So what I'm going to do is I'm going to use these bits of angle iron, I think, and put them on. So I've got 2 of them. I'm going to put them on so I'm going to drill holes in the bottom here so they bolt onto that. I'm going to bore a hole through both of them so that I can put the 1-inch bar through it and probably weld it in place onto here. That way most of this structure is clamped together, and that way it's all got a bit of flex to it. But where it goes through, there'll be a fixed axle in here, which will go onto the, not that one's broken, go onto, it's a good job I brought spares now, go onto there, and then this will be fixed onto a plate on top of the column, and the only actual movement will be inside this bearing and the rocking back and forth. So that's the new plan. Let's get to it. Right, I put it all together and mounted it on a bit of channel that I had kicking about. And I think this time round it actually looks fairly convincing. So we've got way more travel than I actually need. All the stuff on the spring is clamped together with these studs, so it has a bit of flex to it, and the cast iron is on something that's fairly immovable. This will be welded onto the top of the column, so even though it would have been better to have the channel going that way, it wasn't quite big enough. So but yeah, once it's welded on the column, that'll be nice and rigid underneath there, so there won't be any movement. So we're breaking one of these. Even though only £6 each, that represents the most expensive part of the whole project. So I'm going to put something in here, drill and pin that so that the axle can't come in and out. This is just a bit of mild steel. It's 25mm round mild steel. And I'm going to double up the nuts on the top and the bottom of the studs. I'm going to dig out some more nuts and tighten them up, because if this thing loosened off in the middle of an operation, that would be dramatic. So yeah, I'm quite pleased with that. I think that's going to do the job. So this is the sort of thing that would be really handy if there were more details like this on the internet. So let's zoom in a bit. So here's a zoomed in picture of what will be the top of the column with the rocking spring helve. I must say it does feel very nice to actually have some kind of mechanism. This is the first moving part of the machine. On its way. So trying to align the cap on the top of the column needs to be square with the frame below, and what I'm trying to do is use this. I remember I had this rather crappy but occasionally useful laser gubbins. There's a better name than that, isn't it? Laser level perhaps. Anyway, it puts out a cross. I'm not sure any of this is going to show up on camera. So on my hand there is a cross, a red cross, and That's appearing here. So what I'm going to do, if I can pick up the laser beam here and here, then it's square to that. If the same line is parallel to the main RSJ there, then it's all square. So I can check it like that and then move slightly over until the beam's just kissing the edge of the column, and that way I can tell how far out it is over the whole distance, which you can't do with a normal level quite so easily. So by that I can see over the entire length of it. So the beam's just kissing the thing at the bottom there, but up there the beam's 5mm in. I wish I'd had this gadget when I built my pole barn. It would have made life a lot easier. I did it all by eye, and so it's come out a bit rustic. Although it probably would have done anyway. I might be a poor engineer, but I'm a good Ironthumper. So worrying about the guesswork involved at this point. So I'm hoping that if I make this video, go through these steps, like this bit of the linkage, I haven't seen that detailed anywhere else either. So bits like this, if I'm successful, even if I'm not, it'll be useful information. So that's going to be the spring. I've got an actual suspension bolt, which should be the right size to go through. What I think I'll do is put a plate, weld a plate on here and on the other side to make this rigid in itself, in that sense, and then it's just got movement that way. Yeah. Because we don't want slop in the linkage, because anywhere there's going to be slop, it's going to wear itself. Although I have tried to make sure I'm using easily replaceable parts, but I don't want slop in there. That's going to be bad. What I want is for all that, what would be slop, to be pumped as energy into the spring. So that will allow us to work out where that wheel's going to go. Yeah. Right, it's a bit hard to fit all this in shot because it's a vertical thing that I'm trying to describe, and it's a cinematic format I'm trying to describe it on. Anywho, right, so we've welded on the 20mm bar there onto the wheel, and it's quite, yeah, it's got plenty of weld on there, and yeah, I think that's pretty solid. as good as it's going to get anyway. So now I can work out where I'm going to put it in alignment to the spring. So just out of shot is the spring itself. This is the shackle that I've made, and then this is the rest of the tractor top link. Obviously I've cut it here, and so there's the end of it on the 20mm bar, and there's the other end of it. So I can turn this bit here and pull this in and out. So this is set to about the middle of its range. The tyre, the wheel rather, is set at about the middle of what would be the middle of the stroke, so it's halfway up here. And the spring is about the middle as well. So what I'm thinking, if I set it all up here as it is in the middle, I'll then have this amount of adjustment to play with once the thing's up and running. I hope that makes some kind of sense. So what I was looking for was, initially I thought I'd use a 20mm solid bar going from here to here. Then I thought it might look better with or might be better with 25mm, an inch bar. But then I thought, actually, I don't want that much weight here. It's not a good place for the weight to be. I want the weight to be at the hammer. This one, as light as possible, is just going to put more stress on this joint. So I figured probably best to use a bit of tubing. So that tubing will go from there to there. So that's the next thing to do, is to cut this tubing, clean it up, and then weld these ends on it. And then that, once it's all hanging there, will tell me exactly where I want to put the wheel, and hence where to mount the stub axle that's going to hold the wheel. So, right, where was I? So yeah, thinking I'll cut this down to the boss and then turn the boss down until it can fit inside a scuff tube, and then I'll sleeve it with a scuff tube that's about, that'll take out, yeah, that's about so long, so it goes across the full width of the tyre, and then weld it on the inside onto this. That's the plan. Don't know if it's going to work out yet. So the plan was to mount the motor next to drive the tyre, but instead I'm going to work on this bit here. I'm not happy with at all. So this was a pity really, because it's the one bit I fabricated from scratch, and it does look nice and it's nice and strong, but it's not doing the right job. So that there we don't want. So, but as initially I thought, well, this whole thing's wrong, and what I should have done was just connect it straight onto here. But get a better view of it. So the fact that it compensates for a slight movement that way is actually useful. What we don't need is that movement there. So I was thinking maybe I'll put some angle line coming down off of here to restrict that, because most of the time it doesn't happen. But there are situations in which the spring plays back, I think, and then this upstroke here pushes that way or that way. If it goes that way, it snaps hard against the spring, and it's under power, that's going to get messy. But if I put some angle line here, and that will smack against that would restrict it. That would probably do the job But then I thought better to cut through here and turn that 90 degrees. I think that's probably what I'm going to do. I think that will help. Right, on the other end, this is going to be the ram. Not the ram, I mean ram, this is going to be the top. Yeah, that's probably a better way for it. And here I've got more decisions to make as well about what I'm going to do. Obviously this bit of wire is very temporary. Everybody I've seen, just about, has cut off the springs here and put rollers on it here, so that the guide just goes up and down, and the spring is allowed to move in and out of the rollers. But what I'd like to do is to keep this as it is, and the problem, what I'm trying to describe is, the problem is this is coming around in a slight arc, so we have to allow for that and translating that movement, the up and down movement, into what we want. There's going to be this slight arcing going on. So what I'm hoping to do is just get two straps, two bits of flat bar that will clamp on the sides here, and that might just be enough because the guide is going to be down here. This is what I hope to use for the guide, just this bit of box section, which is quite a loose fit inside there. Right, there we have it at the bottom of its stroke. This is hopefully going to be the guide. Now what I'm concerned about is I might have... Oh yeah, that was it. So that's the bottom of the stroke with it adjusted at sort of midway position on the turnbuckle. So that means I want to leave about at least an inch in it. It's not going to leave me much stroke there. So yeah, may have boobied slightly there. Let's find out anyway. So if that goes there, I'll do that one. That goes there. Yeah, bring that down, take a play out there. Yeah, so for the morning, first thing to do would be to remount this, so this is a bit lower down. I'm going to tack weld the brace in, hold the guide in place, and we'll have a play there and see what's what. Yeah, right, see you in the morning. Welcome back. It's even more noise than usual. We're in the middle of a storm at the moment. I'm not sure if that cover's going to last a day. That's the Land Rover I'm halfway through rebuilding. Anyway, back to the point. Right. So what have I done? So this morning, crikey. So I've drilled this to drop this down a bit, to give us some more room to play with there. And then the joint here, what I've done is cut most of the inside out from this link. You can see that. And then I put two 40 by 12, two bits of 40 by 12 flat bar as spacers. And what that does is it means it can only do that now sideways, but it's got more movement. It's still got plenty of movement this way. So as a result of doing this on the joint, now if I spin that round, there's no movement at all there now. It's just transferring straight up into the spring, which is what we want. I can choose where I'm going to put the guide. So with that, that's its lowest point. Yeah, lowest point, and with a little bit of clearance top of the guide, it's out there. And the highest point. So what I'm going to do next is to tack it on to the column, give it a spin and see how it looks. See whether this actually does take up that arc movement like I'm hoping it will. Yeah, pretty sweet. Let's just hope it all holds together long enough and really get a tack on it. Right, see if it goes up and down. So here's the top, and to bring it up to weight, I'm going to cut 12 inches of this 50 by 50, or 2 inch square if you prefer, solid square. This is about so here we go, here's an issue that you need to be aware of. I've allowed for the stroke to go up and down, so if it's running slowly it will run perfectly. But as soon as we get the whipping motion from the spring, there's not enough room. So, bugger. I'm going to have a think on that. That's annoying because the bits that I thought were going to be tricky actually work reasonably well. This whole section is good. The guide, the box section inside this box section, that's all working well. I can see that panning out with some brass or copper guide in there, shims rather. That'll do the job. I like the mounting of it, that's all good. Just lacking a couple of inches. Same old story. Right, I'm gonna try and increase my length. Go back to, well, at least I make myself laugh. Right, I've added that much extra on. Yeah, that much extra. And now don't seem to come more than an inch, even, yeah, but so once there's weight on there's going to be more whip, I think. So I'm not sure even if that's going to be enough. So I haven't cut these out yet. That's going to give us there's a bit of leeway there. If I need it, I can cut those bits out and give another inch to the. What I don't want is for the whole thing to be too low down. So I just guessed at the height of the column. I should have gone a bit taller, really. Anyway, I had planned to put it all on sleepers, which is going to bring up the whole thing. So yeah, we can play with that. That's all right. But so this whole issue has brought up something far more serious, really, and that's this. So I had wondered what material the railway track is made of, and concluded it was probably just rolled steel, because that would be a profile you can roll. You wouldn't cast it, would you? So yeah, I just went ahead and welded it. I just whacked it with a hammer, and that weld has just popped off. There's no, now, you have to take my word for it, there's nothing wrong with the actual welding. I'm a perfectly competent welder. But this is the sort of thing you get if you try and weld cast iron without the appropriate techniques. So there's plenty of penetration with the weld here, and what's happened is it's just pulled off. So yeah, it hasn't taken at all. What I've done is drilled and tapped it, and I've put in these 10mm studs. So what I'm going to do is just tack weld those on this side to stop them coming out, and that will bolt up into these plates, which will go like that. That will be welded onto the 50mm square here, and then that in turn will go inside this and be welded there, like so. Right, so probably said this already, but I've gone with mounting it this way so I can feed in through the side, and I can do tapers of any length. This is going to be, I see this as mostly being for drawing out long tapers, which is the first job that I have for it. I'm going to dismantle this, and I'll see you on the table. I put it on a rubber mat, or a bit of a stable matting, I think it is. Sort of stuff you get in horse boxes. And yeah, give it a roll in here. It's dead flat in here. I'm just a bit worried about the strength of the concrete. I didn't make the floor with the intention of putting an unsecured power hammer on it. Yeah. Still bounce around a lot, but I think it'll do for today. Right, Fabricating. So we're about to go into the second day of use. So it's rattling around quite a lot here. So on the guide, I've cut some of this brass plate and I've put it in there on the front and on the back to decrease the amount of movement back this way. That was hard work. That was hard work, even with power hammer, which did brilliantly, I thought. Did really well. It walks about a bit, but that's to be expected because the poor thing's not nailed down. But yeah, no cracks in the floor. Putting the brass bits in the guide has helped a lot with the play. Taking out a lot of the sideways slot, so that's good. Yeah, I'm very happy with the power hammer. Oh my god, look at the amount of effort it's taken to make these bloody things. And what's the irony is that I've had to build a machine in order to make these look as crude as they wanted them to. So to get that texture on there and to get it to looking like the picture that they sent me, yeah, the only way really was to build a power hammer and do it like that. And these people obviously wanted to look rustically rustic, which is certainly what they got.